short little introduction video on how tables and graphs work on the Desmos graphing calculator. Um, First thing you need to know is that the graphing calculator here can produce many items. It can produce expressions or tables, and you can even work with images and stuff like that. You could start with a table just by typing different data points in. You could get your tables off of the internet somewhere, or like I did here is I just created a table in Excel, and I'm going to copy and paste this data into the Desmos graphing calculator. And all I need to do is get up here in this empty space and hit Control V, and that'll paste that data in nice and efficiently for me. So as you can see these data points over here, the graphing calculator has many different features in how you can adjust your window settings. You can just simply click and drag, or you could go over here to the graph settings, this little wrench, and you can certainly manually adjust each of these step sizes and your lowest value and your highest value on your x-axis. But I'm just going to leave it like right here for now, and I am going to then attempt to fit a best fit line into this data points. Well, there's lots of different ways to do this. You could just start by typing in y equals, and then you could maybe guess and check what values your slope and your y-intercept might be. So y equals 5x plus 2, or plus 1, sorry, and then you can check to see how closely that fits. And that's an okay way to do it if you know a little bit about slope and you know a little bit about y-intercepts. You might be able to predict this pretty quickly and efficiently. But instead of doing this, I'm going to kind of delete all this, and the powerful tool that Desmos allows you to use is enter sliders. So I'm going to enter y equals mx plus b, and we all know that m is our slope and b is our y-intercept, and I'm just going to add sliders for both of these. And now I can try to do a couple things. First of all, I can kind of predict where these data points will intersect the y-axis, and that's my interpretation of b. So I'm going to predict it to be like right around here. Let's start with that. And then I'm going to adjust the slant of this line, or the slope, to try and get it to fit my data points. Now I'm doing a pretty good job here. It's pretty close, but it's still not perfect. So you could just kind of tweak this a little bit and try and, just nudge it here and see, and just try to play around with it until you get this exactly the way you need it. So this looks pretty good. Y equals 2x plus 2 is um, my line that fits this data. That might take a little patience, but if you understand a little bit about slope, you could probably go up here and calculate that by hand, and then put it in those data values and check your conjecture to see if it works. Now, as you look at my data here that I had originally, it's tables and chairs. So if I had one table, I'd need 4 chairs. If I had 2 tables, I'd need 6 chairs. You could fit an equation into this data table that you have. If you wanted to predict out um, how many chairs are you going to need if you have like 50 tables, or if you need to seat 100 people, how many tables will you need to fit in your hall, or whatever you're thinking about here. So I'm going to adjust my window settings a little bit here, and I'm going to make these pretty far out now. Negative tables doesn't make any sense, so I'm going to set my x minimum to 0, and then I'm going to set my y maximum over here to like 100. So that would be 100 in terms of tables and chairs. So this would be the tables, and then for the y, these are chairs. So then if I can't have negative chairs, so I'll adjust my window settings to 0, and I'll also go to 100 here. And now, as you see this, all my data is kind of squished down here in the very close to the x and y axis. But if I wanted to make a prediction and extrapolate this out, I could go down here and make another prediction. If y represents my number of chairs, I could do like y equals 75. If I need to fit 75 people, the intersection of these two equations here is 36.5 and 75. That means I need 36.5 tables to fit 75 people. And likewise, if you wanted to make a prediction with your x values and say, okay, my x equals, x equals, let's go with 25. x equals 25, then I have 25 tables, and that'll allow me to fit 52 people with this model. This is just a quick little short introduction video onto how